right, here we go, 2016 free response. As you're going through these, this problem is going to be graded out of 9 points. I'm going to encourage you to score yourself. So even though you're going to write down the right answers and make sure that you fill in anything that you did not know how to do, try to keep track of how many points you got on your own. And when you're done, if you'd put a score up out of 9 on your paper, that would be awesome. I'd appreciate it. Our goal is going to be to score at least 5 problems on every single problem that we do. And if we get more than that, that is just a bonus. And if we get less than that, well, then we're going to have to try harder on another problem. So here we go. All right, water is pumped into a tank at a rate modeled by W of t equals 2,000 e to the negative t squared over 20 liters per hour. I'm just going to circle my units here. Okay, where t is measured in hours. Water is removed from the tank at a rate modeled by R of t, once again, liters per hour, where R is differentiable and decreasing on t being between 0 and 8. Selected values of R of t are shown in the table above. At time t equals 0, there are 50,000 liters of water in the tank. So the first thing it asks us to do is to estimate R prime of 2, show the work that leads to your answer, and include units of measure. Okay, R prime is a derivative, which is also a slope. So this is the table for R. So if I know I would like to find the slope at 2, I notice that there are 2 points that 2 would be enclosed in between. So I'm going to find the slope of the line containing those 2 points. So my slope is going to be, it would actually be R of 3 minus R of 1 over 3 minus 1. You would not have to write it that way if we just wrote 950 minus 1190 over 3 minus 1. That would give me an answer of negative 120. And units of measure, my R is on the top and my T is on the bottom, so it's going to be liters per hour per hour. So I'm going to put liters per hour, or we could also just put liters per hour squared. Okay, and this was worth 2 points. You got 1 point for getting negative 120, and you got 1 point for the liters per hour squared. Okay, part B, use a left Riemann sum with the 4 subintervals indicated by the table to estimate the total amount of water removed from the tank during the 8 hours. Is this an overestimate or an underestimate of the total amount of water removed? Give a reason for your answer. Okay, left Riemann sum. I notice that the table is not going by equal intervals, so I can't just put a number out front and then add my left regions. So instead, I notice if we want 4 subintervals, this will be my first one, second one, third one, and fourth one. So for that first region, the length of the rectangle would be 1, or the width, whatever we want to call it, the length or the width. For the other part is going to be the left. So in my interval 0 to 1, the left sum would be the 1340. And then plus the region between 1 and 3, that width would be 2. And then the left sum would be the 1190. And then plus between 3 and 6, that width would be 3. And then the left sum in that interval would be 950. And then plus the width of the interval from 6 to 8 is 2 times the left of that region would be 740. So from here, if you just add that up, you're going to get 8,050. And I was in liters per hour. I took this is a way of taking the integral of that, so I would be left with liters. All right, then it asks, is this an overestimate or underestimate? Well, if I were to draw this at all, I notice that this is a decreasing function, so I don't know whether it's going to be concave up or concave down, but it's going to be decreasing, okay? And if I were to draw a left endpoint Riemann sum, we start at the left and draw our rectangle to the right, left to the right, left to the right. I notice that this is going to be, my rectangles are going to be too big, so this is going to be an overestimate. And then it did say to provide reasoning. The reasoning is just simply because the function is decreasing. And the function that I'm talking about is R. So the function R is decreasing. And that's all we need to do, say, for our explanation. You might have something a little bit different for your explanation. Just make sure that it makes sense. This part was worth 3 points. So showing that you did a left Riemann sum, you'd get a point for. Getting the proper answer, you'd get a point for. And saying that it was an overestimate and why, you would get a point. So this altogether was worth 3 points. Okay, part C. Use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of the 8 hours. So this was one of the accumulation problems that we did, and if we want a total amount of water, I'm going to call it A. We started with 50,000 liters of water in the tank, so 50,000. Let's figure out how much is going in. We know that water is being pumped into the tank at this liters per hour. So if I just want it back to liters, I will be taking the integral of that. So it's going to be the integral of W of T. You can either write that actual formula or you could just write in WT. It's going to be from at the end of 8 hours, so it's going to go from 0 to 8. And then minus how much water is going out of the tank. And we already found in part B that 8,050 was coming out of the tank. So we can just calculate that. When we do that, if you did want an immediate and intermediate answer in between, this is 2836.195. And if we go ahead and add and subtract that, we will get 49786. It does say to the nearest liter, so we know we don't have to go 3 decimal places. And amount of water in the tank, liters per hour, the per hour would drop out and we would be left with liters. So this was actually just worth 2 points, unfortunately. If you took the integral, so if you have that on your paper at all, you get a point for just showing that you needed to take an integral at some point in time. And then if you got 49,786, you also got a point for that part. So this was worth 2 points altogether. Okay, part D is going to be worth 2 points. So if you're like, oh, I did not know how to do this one, it was just 2 points. So if we got points on other parts, we're going to feel okay about it. All right, so this says for T being between 0 and 8, is there a time T when the rate at which water is being pumped into the tank is the same as the rate at which water is being removed from the tank? Explain why or why not. So rate at which water is being pumped into the tank is W of T. And rate at which water is being removed from the tank was R of T. We just need to figure out, is there a time where those two rates are the same? And we can't tell for sure. The one thing that I'd have a hard time doing, since there's not a formula for this one, we can't specifically set the two equations equal to each other. So one thing that's usually nice to do, if we're trying to set two things equal to each other, I'm just going to subtract R of T from both sides. Is there a time when this answer would ever equal 0? Okay, so if I want to find out if there's ever a time that this answer equals 0, I'm going to refer back to something that we did quite a while ago, and it's called the intermediate value theorem. Whenever we were trying to find a 0 of a function, as long as we found that on one endpoint the value was less than 0 and at the other endpoint the value was greater than 0, then we would be guaranteed that somewhere in between the value must equal 0. So that's what I'm going to be looking for on this one. So the first one, I'm going to try the beginning of the endpoint. So I'm going to do W of 0 minus R of 0. And if I do that W of 0, if I just plug 0 in for my T on the W equation, I end up getting 2,000. And then R of 0, I can just look it up in the table, was 1340. So I get 660 for that one, which is greater than 0. Okay, and now I'm going to do the other endpoint, which is W of 8 minus R of 8. So W of 8, again, just plug 8 into the W function, and that gave me 81.524. Okay, minus R of 8, just look up in the table, it was 700. This will give me negative 618.476, which is less than 0. So if at the beginning of the interval W minus R was greater than 0, and at the end of the interval W of 8 minus W minus R was less than 0, then there must have been some point where W minus R equaled 0. So I am going to say, due to the intermediate value theorem, since W of 0 minus R of 0 is greater than 0, and W of 0 minus 8 minus R of 8 is less than 0, there must be a value of t such that W of t minus R of t equals 0. Okay, so that was worth 2 points. You got 1 point if you considered this at all. So if you have something about W of t minus R of t on your paper, worth a point. If you were able to explain it and you decided that yes, it was possible and why, then you got another point. So this was a little bit tricky, but hopefully someone out there did get a point.